So the second talk tonight, I think most of us here have heard of this guy. Sorry, I'm trying to be sarcastic, I'm not very funny. Who's heard of Devops Weekly? Pretty much everyone, right? It's the guy who curates it, Gareth works at GDS, now working at Puppet Labs over there. I'm very, very pleased to come to talk on it tonight. So without further ado, this is Gareth Rushgrove.
Okay, so I'm going to talk pretty quickly. If anyone's had me speak before, you knew that already. I'm going to talk about this a while. And it's probably at the end of the general purpose operating system and some other random involved. I'm Gareth R, basically on the internet, if you need to find me. I'm not normally that well dressed. I do curate Devops Weekly, you should definitely sign up, and I work for Puppet Labs. I'm not really talking directly about Puppet tonight, but ultimately, like, if you don't know what Puppet is, then you should know. We help you manage lots of infrastructure. So, this talk is going to start off with a question for you, and just shout it out. What server operating system are you running? CentOS. Red Hat. Ubuntu. Keep going.
Windows.
Someone said Arch. Windows. Keep going. Solaris. Coral. So, that'll do. So I'm guessing most people said, or would have said if they were wanting to shout out, CentOS, Debian, Windows, Ubuntu, Red Hat. I got all those. Someone will try and be smart and say, who said Arch? See? And someone will hide the fact they're running someone said, oh, no. We're running all sorts of what are all really general purpose operating systems. And nearly all of those you could be running on your desktop, on your servers, anywhere you choose to run a computer. And I think that in a period of time in the future will become odd. For some people it's already odd. So some of what I'm talking about isn't that far away for some people, it's a long way away for other people. So don't take this as you should go away and do this now, but do consider that some people are already doing it. So I'm going to talk about sort of four main things. One is this sort of this quest for the hypervisor of containers. Another is this sort of, I guess, who's going to own PID1? Who's going to be the thing that runs everything else on the actual computer? There's also the, well, if we're running everything in containers, what's inside the container that helps our application, if any? And that's not Rise, that's Rise of the Unicode. I got that before anyone else realised. That would probably, well, who's heard of Unicode? Like a small scattering of hands, which is good, because I'll introduce them a little bit. So, before I get to those topics, I'll talk about a few problems. This would be much stronger, I think, with a bunch of data, but I've had a cold, so I haven't really had time to get a bunch of data. I'll sort of posit without any data. The operating systems are really big, both in disk and on memory. They're big, big things. If you've ever gone and looked at like a source tree for a distro, how it's all packaged, they're big things. If you've ever downloaded a Windows ISO, they're big things. Like, I feel like I can find some data to back later. Operating systems take a long time to boot, and we're booting them more often. Again, I think most people would agree we're definitely booting them more often. I can go find some data. A long time is obviously somewhat subjective. Taking a long time to get a new server 10 years ago was a different conversation to one today. Like 10 years ago, it was definitely about getting someone to ship you some kit. Today, it might be that, but you might have got that down so you're getting deliveries every day or every week, depending on how big you are. Or it might be that you just click a button or you send an API call and you get kit really quickly. So that time to boot becomes increasingly important. And I think we're seeing that with developer tools in particular, where we're booting things locally and feeling the pain of things taking time. Operating systems have and part of this is they're big, and so they have lots of bits, and those moving parts need managing and securing. Someone just mentioned another vulnerability. We'll keep seeing vulnerabilities because we don't know how to write software. The whole writing software thing is new. We've invented lots of languages, we've invented a lot of techniques. We don't really know what we're doing yet. Talk to academics about that if you feel like doing so. And the other sort of, I think, central thing is our workloads are increasingly single purpose rather than general purpose. And we've actually got, like, your web stack and my web stack and someone else's web stack for an application probably looks quite similar. Some of that's tooling. We use, broadly speaking, a smaller subset of tools. But using different languages, we tend to talk over HTTP. We tend to talk to databases. I bet you've got a proxy. I bet you've got a load balancer. I bet you've got some firewalls. I bet you've got etc. etc. We're starting to we scale the same ways for the most part. There are exceptions, but they're not the 80%. And there's a sort of problem, like, really, if your web application server has got print drivers and is talking to a printer, you probably have a problem. But for those that can't read, there's a small caveat there that basically says, unless you're moo, at which point, thank you for being the exception that rules the rule. You don't want your web application servers doing all sorts of things that a general purpose operating system is designed to help you do. So, coming to the 4 points I said I'd actually talk about. So, hypervisors have been around a while, and they've been around sort of posited for before then. We're going back sort of 30, 40 years for the sort of academic literature. And there's generally this classification around sort of there being two types of hypervisors. Sort of type 1 being, it's the hardware, and you have a hypervisor on top of it, and then you have your guests. And type 2 being, you've got your hardware, you're probably running an operating system, you're running a hypervisor on that operating system, and then you're running your guests. So something like VirtualBox, like running on your Mac, would definitely be a type 2, it's not running directly on the hardware. Something like Zen or ESX or Hyper-V would definitely be a type 1. Hypervisors up to now have been about, well, it's about virtualization, it's about virtual machines. But we're seeing this sort of push into containers. And what we're seeing with containers is a similar sort of trend to what we saw with virtual machines. Virtual machines were a good idea, hypervisors were a good idea. Now how do we make this real? How do we take advantage of all the things that we can see in a large-scale environment? And there's these sort of, there's definitely moves. I think you can sort of see a bunch of people trying to say, right, we're going to be the hypervisor in containers. And they're generally coming up from the operating system. They're sort of, and I'll explain why that's interesting later. So you've got things like Project Atomic from Red Hat. You've got things like Koros that someone mentioned earlier. You've got things like Snappy from Ubuntu. You've got things like Rancher OS, which is running Docker on Docker, which is crazy and interesting. I'll talk about that a little bit more. They all want to be your new operating system. They all want to be your new hypervisor for running containers on top of. And there's a bunch of common themes that they sort of hold dear that are somewhat different to our sort of general purpose operating systems as we use them now. They tend to be very much cluster native. They tend to be aware, like, compact with features that make it much more about managing a cluster than managing individual hosts. You're still going to have individual processors, you're still going to have individual computers, but the operating system is going to make it easier to deal with those as a cluster, rather than the cluster that we have now. A lot of things are chipping with read-only file systems or parts of the file system being read-only. We talk a lot about immutable infrastructure, or lots of people talk about immutable infrastructure. And then you go, oh, so your file systems are like read-only, and they go, no. And it's like, so you're just assuming that they're immutable. Like, what if someone changes one? And they'll go, oh, no one can change one. Like, walk through it. So your application definitely doesn't have some sort of exploit. It's like they go like, oh, I haven't thought about that. It's a good job I don't work on somewhere that's important. Immutable infrastructure as a pattern is like has a bunch of really solid use cases. It's definitely a good thing to do. But you need things like read-only file systems. You need a bunch of the file system-led stuff to do this properly. Atomic changes as part of that. Like, you can't just have a read-only file system and not be able to change it. At least at the bottom line, you need to be able to change it. You need to be able to change it atomically. Wouldn't it be nice if you can roll back your file system to different states? Some of this stuff like RPM Austrian, you can. And another common theme is they're integrated with Docker. Some of that's because Docker's driving a lot of the buzz around containers. Some of it is, if you don't integrate with Docker, people won't print news stories about you. Both of those two things are valid and true. And what we'll see as well is that all of these things are, they have an aspect of open source about them, but they're also being driven by companies because there's a lot of money in, so like if you get to be the one and only hypervisor of containers. And that sort of pattern of like sort of commercial and open source coinciding is here to stay, and it's definitely here to stay in this sort of like high stakes game. But don't count out people like VMware. And VMware are all Docker supporting some of the new Windows service stuff. They haven't got some of the legacy problems that we have on the Linux side. They've got some other ones, but they're pretty smart cookies. See what they do. There's a sort of subplot around this. And I'm sort of saying that, the ones I've described are sort of coming up. They're coming up from the operating system to be your new best friend. And I think there's a whole bunch of stuff coming down from the user interface. And I think this is a pattern that's emerging for a lot of things. And this is partly down to the importance of the API. Maybe you don't need to own the bottom of the stack. Maybe you can own the top. So the Kubernetes API is way more solid than the Kubernetes application. And there's now a lot of people at Google working on Kubernetes. Both from a Google Cloud Platform point of view, but also from a run it anywhere you want point of view. Mesos is still interesting. Aurora, again, inspired by Borg from Google. Aurora is used for a lot of stuff on Twitter, and again, there's sort of solid use cases for a bunch of this stuff. Don't count out the platform as a service people. The idea was probably solid, and they've learned a lot by doing what they've been doing for a bunch of years, even though it hasn't really massively caught on. Amazon are a monster, and they have Elastic Cloud Service in beta. And again, yes, you could potentially run a bunch of this software on them, but hey, they'll give you their own API to do so. And they're pretty good at owning APIs on ecosystem stuff. And the other thing is Docker with Swarm are ultimately saying, hey, we're not going to do everything, but we are going to want to own a bunch of these APIs. And so with Swarm, they're sort of starting to play in that field. And that's interesting because everyone's integrating with Docker one way, and Docker is saying, well, actually, no, we're going to own, you're not going to disaggregate it out of the way. So that's sort of one thing that's happening. That the operating systems are changing to be much more of a cluster-aware hypervisor for containers. But there's something else happening as well, which is interesting. And it's sort of like who gets to be the thing that owns the processes? Who gets to be on paperwork? And it's definitely a different part of the stack. And there's sort of two things, or two players really. I think we might see more. There's systemd. Like, whatever you think, pay attention, because systemd is going to be everywhere, which is hugely useful. And it's also got some amazing stuff in there. Whatever you think of it, the internet version of systemd, like start paying attention to the technology. And the other player in this sort of ownership of paperwork, I think, is Docker. And I'll come back to that in a second. But like sort of, again, like systemd feels like it's coming up from the Unix system. It's coming up from the operating system. It has a lot of that sort of solidness, but also it has a lot of people on fire. And does it have the sort of the user-friendly tooling around it yet? Docker's definitely coming the other direction. What Docker did incredibly well was they nailed the user interface. They nailed a way of interacting with something that was archaic. Anyone who used LXC and wasn't, compiling their own kernel on their laptop found it difficult. Docker, you didn't, and neither did anyone else you'd ever met who'd ever picked up a computer and tried to program. And that's smart. That's clever. Systemd already contains container functionality with NSpawn. There's a bunch of other overlap in there as well if you go spelunking through the large feature set that systemd has. But the real battle is this sort of who both want to own supervision of processes. And there are a bunch of ways of doing this currently, and they can both sort of coexist. But different people will tell you differently how to do this, and realistically they fight. That integration will get better, but also they're going to keep fighting for who owns the process. So expect more overlap. And I think like ecosystems that evolve together but also separately, there's going to be a fight for big one of these coming into an operating system near you. I'll start going quickly because I'm getting carried. So there's a sort of side track of the operating system inside the container. And there's sort of like, well, what's wrong with running your full distro? What's wrong with running CentOS or Ubuntu? And part of it is you'll be able to see the numbers. But again, it's this size. So I've got a bunch of Docker images there. And I've got things like BusyBox at 2 meg, and I've got things like, well, BusyBox and Java at 160 meg. Ubuntu kicks off at 188 meg. But actually, the moment the moment you've got an Ubuntu container, well, you might be going 200 meg, that's not pretty big. That's 184 packages. If I run, get a couple of times sort of like standardy type run tiny things, that's going to balloon. And that's going to keep ballooning. And that's a lot of things to track inside what's meant to be a black box. So there's things like minimal distros, there's things like BusyBox, there's a bunch of other sort of like tiny Linux things that are interesting. But they're sort of being squashed in here. It's like they're being repurposed a little bit. The idea of building scratch images is literally like there is nothing in the container except for what you put into it. But again, this works quite well for sort of compiled binaries and a bunch of other sort of cleverness. So if you look at how Docker are shipping Swarm, that's a good use case for that. But it requires a big jump from how people package applications and code today. I think there aren't answers here. There's no software really. I think there's lots of opportunities here for interesting tools. I think most people are not going after this today because there's way less money in being the thing you run inside many containers than being the hypervisor containers. But I think we'll see some cool stuff coming from the open source community, like when you all get home and start hacking it. And sort of finish off really is like this container stuff might all be a terrible idea. Because hypervisors actually are awesome. They provide super strong isolation guarantees, often enforced in hardware. For those that don't know, containers provide basically 0 guarantees of isolation. Good luck, have fun. That's not a bad thing, but do not expect containers to provide security guarantees. Hypervisors do this in hardware in crazy, crazy ways based on science. Hypervisors are pretty awesome. There's also incredibly mature tooling and experienced people for running this stuff. Who's got, who's seen adverts for, must have 2 years experience running Docker? Must have 15 years experience running VMware? You'll find a bunch of people. They'll cost you a bunch of money. It's pretty good. So what's a unikernel? It's basically a library to build your own operating system. This is something that there's no user space. Your application is compiled into a kernel. So there is just the kernel. So if you like with virtual machines, you've got hardware, hypervisor, the operating system you're running on the hypervisor, in the guest. You've probably got a runtime and you've probably got your application. For containers, it's worse. You've probably got hardware, you've probably got hypervisor, you've probably got a guest operating system, you've probably got, a container runtime, you've probably got a container, you've probably got an operating system inside the container, you've probably got a runtime for your application, then your application. Debugging that's fun, and the tools don't exist yet. They will do, and systems just ship some awesome stuff out. Unikernels look like this. It's the hardware, a hypervisor, and your unikernel. From an operations point of view, I want that. There are less things. The surface area for attack is tiny. Frankly, if you come up with a compromise for the HTTP endpoint for your application that's a kernel, it's going to crash the kernel. Because you're not going to find, there's no file system, there's nothing there to talk to. It's not that you can't have other problems. It's just that your problems are now smaller, so you can focus on them. They're super fast to boot, and insanely fast. I've seen a bunch of unikernel stuff from some of the projects I'll talk about, where they're booting in request, i.e. you make a web request, and they boot it for you during that request. Or you want a message queue, and it boots in process. It's crazy fast. Read this paper, The Rise of the Virtual Library Operating Systems, go to them all. There's a bunch of projects like OSP, Mirage OS, Cambridge, Erlang on Zen, that are all doing this stuff. There is a tendency for these to be research projects. Do not run your critical stuff on them today, but you might do in the future, especially if you're doing interesting embedded device stuff, or if you're doing super security conscious stuff. I wouldn't be surprised to see unikernels become interesting. So, in conclusion, understanding technology change in these big, large things, and it means understanding the economics of software companies. Why are some things happening and other things not? Follow the money. Don't expect all of this to replace what we have now, but it will run alongside it. Me and John were talking earlier, it's the sort of middle ground of all my infrastructure will run in containers, and sort of ignores the fact that if you go to visit a large enterprise, they're running everything from a hypervisor to Docker and everything in between, and it's not going away anytime soon. You'll be running everything all the time. The emergence of sort of super small devices and the Internet of Things but I think it's interesting from an operating system point of view, and that's where sort of things will tell. Do you want to be running all of these different layers in your boiler? Who's going to be writing? The software is going to be written by us, and it's going to suck as much as the software we write sucks. I do not want my boiler to crash every time I'm away from home. Enterprise app stores, whether you like it or not, they're coming because there's a whole bunch of money in them, and that's why people want to own the APIs and the hypervisor. If you haven't read between the lines of what Docker would like, they would like them to be that. They would like it. So would everyone. Evolution and revolution happen at the same time. So this stuff is happening. People are running a lot of this stuff now in some capacity, but they're running alongside everything else as well. Which I think means lots of changes coming, but also I think it's just more, not moving from one state to another, but for most people in any time that matters. And hopefully that was interesting, useful, thought-provoking.
Jack, it's pleased to hear. Cool. So yeah, sorry, pleased to see it. So Gareth, you sticking around for a little while?
Yep.
So I'll Gareth for the questions. Alois is sticking around. Is Alois still there? Yes, he's sticking around as well, so ask questions.